In the last video, you learned all about motion diagrams, which are another way of depicting motion. Here's an example of a motion diagram, where our object starts off at 0 meters and every second moves 2 meters, or we could say 2 meters per second. We see that at 0 seconds is at 0 meters. We know that the first dot always represents the first second. And then at 1 second, it's at 2 meters. At 2 seconds, it's at 4 meters. At 3 seconds, it's at 6 meters. And at 4 seconds, it's at 8 meters. But what about if the object were to stay in one location? We can actually depict that on a motion diagram as well. So let's say after the object gets to 8 meters, it stands still. So that at 5 seconds, our object is still at 8 meters. I can represent that by a dot located above the previous dot that was at 8 meters. What if it's still standing still at 6 seconds? We add another dot. And at 7 seconds, we add yet another dot. This diagram would now indicate that my object remained at 8 meters from 4 seconds until 7 seconds. Now we can also use a motion diagram when an object turns around and moves in an opposite direction, as opposed to what the previous video said. This is actually possible. It's just not quite as simple as the diagrams we've already learned about. Let's look at the reason that's not quite as simple. Let's say we have that same object that's going from 0 to 8 meters at a rate of 2 meters per second for 4 seconds. So we start off with our same 5 dots and 4 arrows that we had at the beginning. However, let's say that same object then turns around and moves backwards a bit more slowly. Well, you'll see this diagram, it's not very clear if my dots overlap. I can't really tell which one was forward and which one was backward and which arrow is which. So instead of having these diagrams or these images right on top of each other, we'll actually move those dots from when our object was moving backwards just up a level. And when we do that, we see that all of a sudden our object is moving in the opposite direction and moving slower because our dots are closer together and our arrows are shorter. In this diagram that we now see at the bottom of our screen, our object started at 0 meters. At 1 second, it was located at 2 meters. At 2 seconds, it was at 4 meters. At 3 seconds, it was at 6 meters. At 4 seconds, it was at 8 meters. And then at 5 seconds, it was also at 8 meters. At 6 seconds, it was at 7 meters. At 7 seconds, it was at 6 meters. And finally, at 8 seconds, it was located at 5 meters. We'll practice this a bit more in class.